pay attention over here because this is VT graph, and VT graph is very important. Area under VT graph is the displacement. So what do we mean? So this is what I mean. So I'm going to make it green. So area under VT graph is the displacement. Okay, so this green and this blue. So area under VT graph is the displacement. Okay. This is my dt. This is my VT. And AT is easy, so I'm just gonna not paying too much attention to AT. So AT would be easy. Okay. So the dt, displacement versus time, velocity versus time, and acceleration versus time. Okay, good. So this is 0 second, this is 1.5, and this is 3 second. This is 0 second, this is 1.5, and this is 3 second. This is 0 second, this is 1.5, and this is 3 second. Okay, good. Now 1.5, I think I can write a little better. 1.5. Okay, good. So at 0 second, displacement is 0. That's good. Okay. At 1.5 second, displacement is 11. This is 11.25. So let's say this is 11.25. Okay. So 11.25 is right here. Okay. And at 3 second, displacement is 0. So this all add up. So right here, and right here. So you just connect this 3 dot. All right. So this is the displacement versus time graph of the ball you just throw in the air. It leaps 1 meter above the ground, and it lands 1 meter above the ground. On another word, it lands on the exactly same height it leaves. Okay, good. This is the velocity. This is the distance versus time graph. Now we're going to convert it to the velocity versus time graph. All right. So let's see. So the velocity. What is the velocity? Initial velocity is 15. What is the final velocity? Is negative 15. Okay. All right. So at 0 second, at 0 second, the velocity is 15. So that's what I'm going to do. Velocity 15. At 1.5 second, the velocity is 0. At 1.5 second, the velocity is 0. All right. In this graph, the velocity is 0 right here. In this graph, velocity is 0 right here. Okay. It should make sense. At 3 second, the velocity is negative 15. At 3 second, the velocity is negative 15. Okay. So, all right. Very nice. Now, we're going to do the acceleration graph. Acceleration graph is very easy. Acceleration graph is at 0 second. At 0 second, the acceleration is negative 10. So let's say this is negative 10. At 1.5 second, acceleration is negative 10. Okay, so this is negative 10. And at 3 second acceleration, so acceleration is the same. Okay, good. Now I'm going to come back over here, and I'm going to pay attention over here because this is VT graph, and VT graph is very important. Area under VT graph is the displacement. So what do we mean? So this is what I mean. So I'm going to make it green. So area under VT graph is the displacement. Okay. So this green and this blue. So area under VT graph is the displacement. Okay. So what do we mean? So let's first find the blue area. And I already know what is blue area. Blue area is 11.25. Why did I write 11.25? 11.25. And what is the green area? Is negative 11.25. Okay. So blue area minus green area is 0. That's why the displacement is 0. And the blue area plus green area is 22.5. That's why the distance is 22.5. Those of you who did not understand the math should understand now, because visually this make more sense. So let's first do the blue area. The area is half BH. So then area is half B is, so the base is 1.5. So 1.5 and height is 15. Okay, so 25. Okay, so this is 11.25. Now we're going to calculate this one. I'm going to use the, of course, green. So I'm going to calculate this one. So half BH. So half B is the base. So the B is here is 1.5. And H is the height. Height is negative 15. So it's negative 1.5. Negative 11.25. Okay? All right. So what does that mean? So I forgot to put negative. Okay. So positive 11.5, negative 11.5, displacement is 0. Positive 11.5, because since this is negative, you take the absolute value, you make it positive 11.25, that's 22.5. That's the total distance. Total distance is blue plus green. Total displacement is blue minus green. Okay, get it? We're going to use another formula to do that. Long time ago, you saw me using this formula many times. So displacement is equal to average velocity times elapsed time. Average velocity formula I gave you many times. Now it comes handy. V plus V naught over 2. So displacement is V plus V naught over 2 times elapsed time. Okay. So what is V? V is very simple. V is 15 and V naught is 0 over 2 times elapsed time is 1.5 elapsed time for the blue. So this is 11.25. Now we're going to do the other one. So now other one is, of course, same formula, times delta t. So this is V plus V naught over 2 times delta t. V is what? What is the V? B is 50. B is 0. B is negative 15 plus V initial is 0 over 2, and elapsed time is here 1.5, and that is negative 11.25. So there is hundreds of ways you can do the same thing. Okay, so hopefully you understand this. If you understand this, that means you are in good shape. Next time you're going to do the physics when you throw something down.